In this video, we're going to go through the basics of atomic structure. Two terms that you need to know right away are an atom, which is the smallest unit of matter, and an element, which is a chemical substance that cannot be broken down into simpler substances by ordinary chemical processes. So maybe you've heard of the periodic table of elements. There's some familiar faces on here. We've got, let's see, hydrogen, helium, oxygen, nitrogen, carbon. So another way we could refer to this is the periodic table of simple substances, because we can't really break those down into simpler things using ordinary chemical processes. There are a way to break them down into subatomic particles, but that's really complicated and beyond the scope of our class. So atoms are really small. So this number right here, remember, if you have a negative exponent like we have here, that's a really small number. Atoms are so small we can't see them with our eyes, and we use an atomic mass unit rather than having to write out 1.66 times 10 to the negative 27 anytime we're working with masses of subatomic particles. So again, an atomic mass unit is just a simpler way of writing out something like this. It's a simpler way of writing out that number right there. So we have some subatomic particles that make up an atom. So we have protons, neutrons, and electrons. Okay, so if I have an atom here, sorry, my circle's a little lopsided, but if I have an atom, we're going to have some electrons that orbit our nucleus. I'll just draw a few of them in here. And then in our nucleus, we have protons and neutrons. So location of protons is the nucleus. Neutrons are also located in the nucleus. And those rings that are around the nucleus, we refer to those as orbitals, or the electron cloud. All right. So the mass of a proton is 1 AMU. The mass of a neutron is also 1 AMU. Now, electrons are so much smaller than protons and neutrons, like a lot smaller. So for the purposes of our class, we're going to say that they don't have mass because it is so small. So it would be like if you stood on a bathroom scale, let's say it read 150 pounds. If you picked up a grain of rice while you were standing on that bathroom scale, it would still read 150 pounds because that grain of rice is so small and so insignificant compared to you that it doesn't really matter. So think about electrons that way. All right, protons have a charge of +1. Electrons have a charge of -1. Neutrons have a charge of 0. So they're neutral, which you kind of see in the name there. Okay, so the electron cloud is the area surrounding the nucleus. That's where the electrons exist. Overall, it's negatively charged because electrons carry a negative charge, so naturally the space that they take up is going to be negatively charged. Now, just like our solar system, you've got like the sun here, and the planets, like in pictures, orbit really close, but like if we were to like actually look at the universe, like all the planets are like really, 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 really far away. They orbit really far away from the sun. So electrons are kind of the same way. They are really, really, really far away from the nucleus. So most of our atoms is just empty space. If you looked at our own solar system, most of our own solar system is a lot of empty space because the planets are so far away from the sun. Okay, some other terms you need to know. Atomic number. Atomic number is equal to the number of protons. So if I go back to my periodic table, and if we pick a symbol like hydrogen, so hydrogen in the lower in the upper right-hand corner, let me just move this over here. So hydrogen on our periodic table is number 1. It has 1 proton. That's what that number means. The number of protons determines the identity of the atom. So if I have 2 protons, that's helium. If I have 3, it's lithium, 4, beryllium, and so forth. So the number of protons determines the identity of the atom. The mass number is the number of protons plus the number of neutrons. So if we go back to our table here, the mass comes from the neutrons and the protons, because those are what really contribute to the mass. Remember, the electrons are so small and so insignificant that they don't really contribute anything to the mass. So when we talk about the mass number, we're talking about the number of protons and the number of neutrons. Now, atoms always have the same number of protons and electrons. We say they have a neutral charge. So again, atoms always have the same number of protons and electrons. In a later lesson, you'll learn about ions, which are when you have a different number of protons and electrons. But when we talk about atoms, atoms always have the same number of protons and electrons. So let's look at an example. It tells us we have a mass number of 23 and an atomic number of 11. So remember, the atomic number is equal to the number of protons. So if our atomic number is 11, that would mean that we have 11 protons. It doesn't tell you how many electrons it has. It doesn't tell you if it's an ion. So we assume the number of protons is equal to the number of electrons. It's an atom. Now the mass number is equal to the protons plus the neutrons. So if we know the number of protons are 11, we don't know the number of neutrons, but we know it has to add up to 23 because that's the mass number. So to get the number of neutrons, we would subtract the 11 and we would end up with 12. So we have 12 neutrons here. Now, if we go to our periodic table and look for number 11 is sodium, Na. Okay, this is isotopic notation. So when it's written in isotopic notation, X is going to be the symbol. So for the last one that we just did, it was sodium. It would look like this. We'd have sodium in the middle. Z represents the atomic number. And if you go back and look, sodium is number 11. A represents our mass number. So in that last example, our mass number was 23. So I would write 23 up here. And then B is our charge. Since this was an atom, it had the same number of protons and electrons, so we would not have a charge here. So we would just leave that blank. If we had more electrons, our charge would be negative. If we had more protons, our charge would be positive. But that's for a later lesson. Let's take a look at another example. Here we have aluminum. Aluminum down here, this number is the number of protons. That's our atomic number. I don't see a number up here. That's the charge. That refers to whether we have more electrons, more protons. So we assume they're the same here. This is an atom, so they're going to be the same number. And then this number up here is our mass number. Our mass number is equal to the number of protons plus the number of neutrons. So 27, which is our mass number, equals the number of protons, we know is 13, plus the number of neutrons. To get the number of neutrons, we would just subtract And let's see, 27 minus 13 is 14. All right, let's take a look at another one here. This time we have chlorine. Chlorine is number 17 on the periodic table. I don't see a charge, so the number of protons is going to equal the number of electrons. And our mass, 35, is equal to protons plus neutrons. We have 17 protons. We don't know the number of neutrons, so we would subtract here. So let's see here. We've got 18. Well, there you go. Okay, now this one looks a little bit different. Carbon 14. So when it's written out like this number right here is always the mass number when it's written this way. So to get the number of protons, it tells us that it's carbon. If we go to the periodic table and find carbon, it's number 6. So that means it has 6 protons. You're not going to have a charge when it's written this way. So we assume the number of electrons is equal to the number of protons. Just like before, to get the neutrons, the mass number is equal to protons plus neutrons. So if our mass number is 14, we have 6 protons. To find the number of neutrons, we would subtract. So we'll end up with 8. All right, one more. Nitrogen 16. Mass number here. Nitrogen on the periodic table is number 7. So it's going to have 7 protons. No charge here, so we're going to have 7 electrons. Mass number 16 is equal to 7 protons plus some number of neutrons. To get the number of neutrons, we would subtract, and we end up with 9 neutrons. And those are the basics of atomic structure.